Hi, I'm Jerome from Fastlane. Welcome to this series on the Cisco Unified Wireless Networking solution. In this series, we're looking at the Radio Resource Management RRM and check how it works. This is the fourth video on this series. In the previous videos, we checked how RRM was working, how messages were exchanged between access points and used by the RF group leader to change the power level of the access points and the channel of the access points. And we look at some key information and look more in detail at channel assignment. In this video, I would like to give you some more information about the power level. Power level is transmitted through the RSSI level. So what you need to understand is that the RRM messages exchanged by the access points will be received at a certain level. This level will be written in the LWAP information that the access point will be sending to its controller for reference. So each access point will be seen as hearing its neighbors with a certain power level. And our aim here is to try to have next 70 dBm as a sort of a target for all the access points. For the power control algorithm to be triggered, you need to have 4 access points in the same radio environment. In other words, if you have 3 access points hearing each other, the RRM algorithm will be triggered for the channels, but will not be triggered for the power control. You need to have 1 access point hearing 3 others with a certain level for the RRM power control algorithm to be triggered. So by default, they need to be at next 70 dBm, minus 70 dBm RSSI away, at least, and you need to have 3. You cannot configure how many access points you need to have around you. These 3 values, that you say 4 in total, right? You plus 3 others around you is a fixed value that you cannot change. The threshold, the minimum value that the access points must have around you to trigger the RRM threshold is something you can configure. I'm going to show you how you do that. Another thing that you need to know is that the RRM power control, which is decided by the RF group leader, is only able to reduce the power level. Well, I would say if one access point reboots, then the RRM is going to send its value to its max power, so somehow the RRM power control can also have an access point using max power. But when the algorithm is triggered, it's going to reduce the power level if needed. There is another parameter, which is the coverage hole detection, which works on the per controller basis, which is then able to increase the power level of the access points, but the RRM power control is decreasing it, not increasing it. Let me show you how this works on a controller. So here I have my controller here. I'm on the A channel RRM TX power control, and you see here it's set to automatic. If I say on demand, I'm going to say invoke power update now, but here again, just like the DCA we saw in the previous video, if you click invoke power update now, the RF group leader is going to compute what needs to be done, but it's going to be done at the end of the next 600-second period. And then it's going to reduce the power level of some access points if needed. Of course, if you say fixed, you decide what should be the default value for your access point power level. You probably know that for each access point, you can go to the radio itself, and for each access point decide which power level should be set. So here you see that the power level is set to 1 with a star that says it's globally controlled. If you go to the access point configuration and you check custom here, you can decide regardless of the global settings what the power level of this access point should be. Okay, you saw here that you have a certain number of neighbors and that you have a power threshold that we just saw here. So that's something you can change from the CLI. If you connect to your controller CLI and if you say config advanced 802.11a and question mark, you'll see that you have TX power control threshold. So if you say TX power control threshold, you can decide what should be the threshold. So again, here remember, the threshold is what should be the power level of at least 3 neighboring access points to trigger this algorithm. So it's next 70 by default, but depending on your environment, you might decide to increase it if you have a large environment with access points far away from each other, or you might want to decrease it if you are in a very dense environment with a lot of access points around next to each other. So let's say, for example, I'm in a vast space and I want to increase it to neg 78. I just say neg 78. And if I go back to my screen here, and if I refresh the screen, you can see that here I have now neg 78. The power neighbor count itself cannot be changed. Okay, next video we're going to look at the last feature we want to have a look at, which is the coverage hole detection.